Okay, so good morning everybody. This is our second lecture and I will go through the second lab sheet and will explain basically how we're going to build our little network inside our virtual machine in the labs in the computer. This is the most demanding lecture, so I will need your attention for quite a while for this, simply because I'm going to explain a few of the networking aspects in this that takes some time to explain. Okay, so the idea behind this is that you have built your Prometheus virtual machine. So now you have a virtual machine that is strong enough to run on your account, and it has enough memory and CPU cores for it to be able to run other virtual machines, in fact an entire network inside it. So what we will do in this lab session is we will use VMware Player in order to install and configure all of the virtual machines that we will need to have in our network in order to play around with the technologies that we want to play around. So we want to do a little bit of networking with CIDR, and we want to do a little bit of routing as well. In order to do this, we need to have a few computers at our disposal, and we're doing this via the method of virtual machines. So what we will eventually create is we will create the network diagram that you see here, minus the grayed out area, because that's for the next lab sheet and I really don't want to confuse you all. So essentially we have our Prometheus virtual machine, which is the one on the left, and we will need to configure our 3 more virtual machines inside it. These will be nested virtual machines, so essentially they're like a little babushka doll of virtual machines. So 3 VMs inside the VM inside your host. So in order to do this, we first of all need to have VMware Player as a software inside our Prometheus. So remember, this already exists on the host, so VMware Player exists on the host, so when you come into the lab and log into the computer, you will find VMware Player there, and that's where you will have installed your main virtual machine, your Prometheus. So now we're repeating this process, we're installing VMware Player inside the virtual machine that you've built, and we're going to create the 3 virtual machines in there. I think we could make a drinking game out of this. Drink a shot every time I say virtual machine. You'll be completely drunk by the end of this. However, the video is recorded, so you can do this at night. So, VMware Player, we're going to use version 17, which is the latest that exists out there. All you need to do is go to the website, follow the link there, and install it. Now, in order for you to install it, you need to download it, and you need to also give it the right permissions. Don't forget, you will be running all this as root. So you need to be able to actually execute whatever you download from the network. So in order to do that, you need to use the chmod command. So the commands will be in the lab sheets in bold letters, so that you know that it is actually a command. And you should be able to basically copy and paste the commands from the lab sheets into a terminal itself. You need to be a little bit careful about syntax, or for example about versions of software. So at the time when I was writing this lab sheet about a month ago, it was version 17.50 and then all of that behind it. The version that you might download might be slightly different in the end, so just make sure that you have the name correct, and as it says in the parentheses as well, make sure that you get the correct file name before you do that. So you execute the command. It's a .bundle, so it's essentially a customized installation script provided by VMware and built specifically for Red Hat based operating systems. And you need a dot and a slash to run it in front of it, just like you would any other script in Linux. Once you do that, then the installation will start, and it will ask you a couple of basic questions. It will ask you to accept some licenses and so on. Just accept everything as default and move on to the end. Now, once you've installed your VMware Player, you need to build your virtual machines. Now, in order to do this, we need to convince your Prometheus virtual machine that it is capable of running little virtual machines inside it. Okay, so we need to enable the nested virtualization feature. In order to do this, we need to tell the CPU of the virtual machine that it has the ability to actually run virtual machines inside it. We need to give it virtualization extensions. So in order to do this, you will need to power off your Prometheus virtual machine completely. Go to the host, open VMware Player, and go to the settings of that virtual machine and find this option, virtualize Intel VT, and so on. Check that box and then start up your Prometheus virtual machine again. If you don't do this, when you try to run VMware Player and build a virtual machine, it will come up with an error message and will say, oh, cannot run this, no virtualization extensions found. So it will stop you right there. Okay, so very important to do this step. Another component that you will need in order to build your virtual machines inside the virtual machine is the actual ISO image of the operating system itself. So you've used it before because you found it on your host. It will have been in your global directory, and you need to make sure that you get a copy of this ISO image from the global directory from your host computer inside, let's say, the downloads or the root folder of your Prometheus virtual machine. In order to do this, the simplest way to do it is to go onto the host, go inside the folder where the ISO image exists, so it should be in your global folder, open a terminal there, and then just type the scp command. So that will copy as user root onto computer Prometheus into the directory root downloads, anything that's called Rocky star. So it will be Rocky ISO image, whatever it is. So if you do this command, it will take a couple of minutes and it will copy the ISO image from the host inside your Prometheus virtual machine. So now inside your virtual machine, you have your virtualization hypervisor, you have your VMware player, and you have the ISO image from which you will build the operating system inside those VMs. You open a VM player inside Prometheus, and you create a new virtual machine. You give it a name again. You call it UP, your student number, and we'll call it VP0 because the virtual machines will be called VP0, VP1, VP2, VP3 later on. Okay, and because the names are long enough already, don't just write the whole Prometheus thing again. All right, let's just stick with VP something. Okay, 4 GB of hardware space, 2 GB of RAM, 1 CPU, and let's leave the networking at this point to network address translation, which is the default method of networking for VMware, and it's the easiest way for you to get internet access into your virtual machines. Go through the installation, create a root password, give it a localhost 1 root password, and create a user account that you will not actually use with whatever password you want on it. Now at this point, you will have built your first virtual machine inside your main virtual machine. Okay, so you will have a VP0 inside Prometheus, inside your host. So we're now 2 levels in. Okay, we need to make sure that we have at least 2 more virtual machines in that level. So in the same level as your VP0, we need to have VP1 and VP2 as well. You could build them again by following the same process. However, there is no point in doing this because you can simply clone an existing virtual machine. So you can take VP0, you can actually find the files of VP0 inside /root/VMware and copy and paste the files next to the folder where they are already at. So you create 2 copies of that folder. The system will automatically name them vPrometheus0 copy, vPrometheus0 another copy or whatever. You rename them to VP1 and VP2. And then you simply start up VMware Player and you choose start a virtual machine instead of creating a new virtual machine. Find them and run them. You do this, you start them up, you rename them as well once you're in them, and then you have all of your 3 virtual machines built in your little virtual network. So you can have 3 computers that are running inside your Prometheus VM at the same time, and you can play around with them. Now for us, playing around with them means networking them together. So we want eventually to have full internet access on all of the virtual machines in our network. So we'll do this in stages. By the end of this lab sheet, we will make it so that we have the correct IP addresses and everything that we need for our 3 virtual machines, and they should be able to ping their neighbors. All right, so we will have 3 virtual machines that live on 3 different subnets, as we call them, 3 different network segments, and they should be able to ping their neighbors, because the next lab sheet after this will actually be routing, because they will be on different subnets, which will give them full internet access to the outside world. So, how do we do this? In order to do this, we need to create what is on this diagram. So we need to have network cards that connect to other network cards in the virtual machine, and then all of this needs to connect to the outside world. There are different ways in which you can create a network in a virtualized network. There are different types of networks. So by default, VMware and most of them do NAT. So NAT is network address translation. Network address translation is what all of your routers have at home, and you get your Wi-Fi and network in your system. Okay, so you have a public IP address which belongs to your router that connects you to your internet service provider. And then once that router starts up and gets this public IP address, it then creates a pool of IP addresses inside it for its inside network, usually starting with 192.168.0 something. And those are private IP addresses. So your router itself does the translation between the private IP addresses in your network and the public IP address that it has on the outside of it. Who can think of a reason of why this happens? Why don't we just use public IP addresses for everything? Yes?
We would run out.
Yes. All right, IP addresses are finite, and it's a very scarce resource as well. Okay, so we use private IP addresses, we do nothing, so that all of those billions and billions of devices that need an address so that they can be found without us running out. All right, so nothing is the default option for virtual machines in VMware. We also have Bridge, which essentially connects your virtual network to the same as the outside world's virtual network. So if your router was bridging, for example, then you would have public IP addresses in your house that would belong on the same network segment as the public IP address of your router. Okay, you wouldn't normally do this in a, at home or anything, but a business would possibly do this if it had servers that need to have easy outside access, or for whatever other reason they do this. So this is bridge, and then we also have host only. The host only is a sort of cheating way of getting whatever the heck IP addresses we want in our network without actually giving a damn about anything to the outside world. So if you have a host only configuration, you can have whatever type of IP address you want inside your network, public, private, it doesn't matter. However, that doesn't generally communicate with the outside world. So it gives you the flexibility to play around in an isolated environment, but it doesn't normally allow you to connect to the outside world. Okay, so out of those three methods of networking, what we will do is we will have a customized version of host-only networking for our networks. We want to use public IP addresses for our virtual machines because we do want to route to them later on. Okay, so we will use a customized host-only version, and in order to do that, we will use a script. That script is called VM_subnet, and if I look for it on my browser, it looks something like this. Okay, I don't want to zoom in, it will mess everything up. You don't need to worry too much about what it does. This script is available on Moodle and you will need to download it. If you download it, or when you download it, you can go through the comment and read everything it does. I will concentrate on this paragraph here. It basically starts up virtual network cards that we call VMnet, and it configures them with the correct networking information. So this will happen in a semi-automatic fashion for you. So when you run the script, it will ask you what IP address and what network address you want to give to your networks that you're using. Okay, you don't need to worry, you don't need to know all the ins and outs of the script. You can go through the script and read. Everything is annotated, pretty much every line is explained, it says what it does. You can have a look through it. It's just a bash script, basically. Okay, so that script will give you the ability, let me find it, to create and configure the VMnet network cards. So this Prometheus, I need to tidy up this a bit. So your Prometheus virtual machine will have 3 network cards in the end. So it will have its network card that connects to the outside world, that gives internet access to Prometheus. Okay, and that is bridged to your host. so that will stay like that forever and it doesn't change. Okay, and then you will have two virtual network cards which are called VMnet 0 and VMnet 1. VMnet 0 and VMnet 1 will provide you connectivity to the virtual machines that you've just built. So your VMnet 0 on Prometheus will connect you to vPrometheus's 0's VMnet 0. It's a mouthful, fine, okay. Alright, so we're creating network cards so that you can use them as virtual network cards, as software essentially, that connects your virtual machines together. In that sense, we will need to give our virtual machines a network card as well. We will actually need to give this virtual machine VP1 two network cards so that it then connects onto VP2 as well. So how do we do this? First of all, we need to start the network cards and configure them as network cards on Prometheus and as processes that are running on Prometheus' system so that the virtual machines can then start up, and when they ask which network card do I use, you can tell them you can use VMnet 0 or you can use VMnet 1 and 2 and so on. So in order to do that, if you run the VM subnet script, then that will essentially create your VMnet 0 and VMnet 1 as network cards and give them IP addresses as well. So when you do a listing of all of your network cards on Prometheus, you will see your ENS33 or whatever it's called, which is your physical network card, and then you will also see your VMnet 0 and VMnet 1s with their IP addresses. And you will also have two more processes that are called VMnet 2 and VMnet 3 that are running on the system, don't have IP addresses, but exist as devices so that you can use them in your virtual machines. Once you do that, then we need to configure the newly built virtual machines to actually use those network cards. Now those virtual machines, by default, they will accept the three default types of networking that VMware offers. So that's NAT, bridge, host only. We're messing with it. We're using a custom network setup, which yes, it is host only essentially. However, it is customized by us. So in order to do this, we need to hack the virtual machine's configuration file, the VMX file, and change it. So we need to change its networking abilities. We need to tell it that it can actually use custom network cards. So that's why we have another script here that's called fix vmnet dev. That is also on Moodle. You'll have to download it. You'll have to save it inside the folder of each of the virtual machines that you've created and run it. You don't need to edit anything inside it. Again, it is annotated, so you can open it and you can have a look and see what's what. And then once you run this, the settings of those virtual machines that you've created will have the ability to have 3 custom network cards each. So once you get to that point, you'll go to the settings of the virtual machine and you will say, okay, my VP0 only needs 1 network card, so I'm going to delete the second and third cards, and I'm going to choose dev vmnet 0 as the network card that I'm using. You're then going to go into VP1 and you're going to say, I'm going to need 2 network cards, delete the third one, and I'm going to use VMnet 1 and VMnet 2 for this virtual machine. And in the same way, in VP2, you'll delete the second and third network cards and let it use only VMnet 2 as its 1 network card. So essentially now, if we had physical computers, we would be connecting the cables to the network cards and installing the network cards in the boxes. Okay, so once we have this structure in place, it means that physically, virtually, we will have the network cards onto our virtual machines and they're all connected to each other. So what's left in all of this? Now that we have the infrastructure in place, we need to give them IP addresses. Now in order to give them IP addresses, we need to know which IP addresses we want to give them. And in order to do this, we have this guy here. This is our map of IP addresses for the lab itself. We have our lab. Everything in the university runs on 148.197.0.0. Okay. The university owns this Class B network with its 65,000 IP addresses. So, the lab itself runs on subnet 28. That's why we have this column here. And these numbers here denote the IP addresses of the hosts that we have in the lab. So our hosts are running from 28.1 all the way to 28.48. Okay, we have 48 computers in the lab, and those are their IP addresses. Your bridged network cards for your Prometheus virtual machines will have whatever this address is plus 50. So they will still be on subnet 28, but they will be 51, 52, 53, and so on. Now, for the virtual machines that we're using, we want to have different networks. So we want to have subnets 30, 31, and 32. So the addresses for the virtual machines themselves will be, let's say, 148, 197, 30 dot something for the Prometheus 0, 31 dot something, and 32 for something for the other VMs. How do we make sure that you don't all use the same IP addresses on subnets 30 and 31 and 32? So we need to have a way to split, like a pie, basically, all of the computers in the network and split the network space. So to do this, we're using CIDR. So that's classless interdomain routing. And in order to do this, we basically need to change some of the networking properties of the networks that we use. So we allocate the IP addresses according to whatever computer they're sitting on. So let's say, for example, that you're working on Farina. Your computer will be on network 30. The segment on network 30 that Farina can actually use starts from 0 and goes to 3. This means that you have your network address that is a 30.0, and then you have a broadcast address that is a 30.3. The usable IP addresses for your VMnet network cards are your usable IPs in between. So you get 2 IP addresses per network in order to use. And they should be enough because if we go back to our diagram, we only really need 2 IP addresses per subnet. Okay, so if we're working on subnet 30, we're talking about this up here. So we're talking about, subnet 30. We have how many network cards in this? We have the VMnet 0 on Prometheus, and we have the VMnet 0 on vPrometheus 0. So we only really need 2 IP addresses for our network. And this is the basic principle of how we do CIDR. We figure out how many IP addresses we need, and then we create a network that is tailored to that need. So in our case, we only need to have 2 IP addresses because we only have 2 network cards in this little subnet, in subnet 30. So we need to make a network for ourselves that is small enough to fit everybody in the class and actually serve our needs. So this is what happens in this. So our network of 30.0 to 30.3 will fit the 2 IP addresses inside it, and we can use them. So we can use 1 and 2 for Farina, we can use 5 and 6 for Hawthorne, we can use 9 and 10 for Ascari, and so on. So this way, we go through all of the computers in the lab, all 48 computers, and we have enough IP addresses for all of them. We also have some spare IP addresses as well. Okay, and this is down to the way that we actually do this. So how do we do this? We have network 30.0 that starts at 30.0 and ends at 30.255. So this is what we call a class C network. All right. So it starts at 0, it ends at 255, and it can fit 254 computers inside it. We have 254 usable IP addresses inside it. Okay. Now we want to fit enough IP addresses, we want to break this into enough slices that will fit all of the computers in the lab. How many computers do we have in the lab? We have 48. So we need to divide 254 by 48 and see how many addresses are left. Because the number that comes out of this is not a power of 2, and I will explain why this has to be, we need to have more. So we cannot have 26 computers. Okay, it always needs to be a power of 2. So we can have 256, or we can have 128, or we can have 64, or we can have 32, or we can have 16, 8, 4, and so on. So it always has to be a power of 2 because of the way the IP addresses actually work, and I will explain this as well. So we're looking to accommodate 48 computers. The number that accommodates enough of those 48 computers is 64, because 32 is too small, yes? So we have 64 lines in this, hence the spare IP addresses. So we've taken our entire network and we've split it into 64 slices. This way we can fit our 48 computers and we can have some spare computers as well. It just happens, it's an accident. Okay, so now because we're splitting a network into 64 slices, we need to know how big those slices are. This is explained in the best way possible on this, my favorite geeky website, firewall.cx, right? So there's a link to this on Moodle, so you can go to it. And if we look at them, so, big enough? Let's make it bigger. Okay, so we have an IP address and we have a subnet mask. So IP addresses exist in decimal only for human convenience. IP addresses, as everything else in computers, is binary, zeros and ones. Okay, so the way that we build them is IP addresses have 4 parts, and each of those 4 parts has 8 bits inside it. All right, if we take those 8 bits and we try to convert them from binary to decimal, so something that looks like 1111111, in decimal, it would be 255. Why? Because it's 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. If you add all of these numbers together, they give us 255. If a subnet mask is on 1 or any address is on 1, it means that it's enabled, and it means that we count that number. Okay, so for a default class C subnet mask, we would have 255.255.255.0. This means that the first 3 octets of this are ones, and the last one is full of zeros. In our case, because we split the network into 64 slices, we need to take away some of the bits out of this and use them as network slices. So we need to take away a few of those bits. In our case, if I go back to our diagram, our subnet mask looks like this. This means now that we've taken this last part that was all zeros before, and we've split it, because these can give us 64 combinations of networks, and these can give us 4 numbers. So in binary to decimal conversion, we have 00, 01, 10, 11. So that's the 4 numbers, and those 4 numbers are 1, 2, 3, 4. So the last part of that subnet mask is what we call the host bit, and it gives us the number of available hosts per network. The other part that we have is the subnet part, and that gives us the number of available networks that we will have. In our case, those networks are 64, which is 2 to the power of 6. Okay, so that's why it has to be 2 to the power of something, and we cannot just divide whatever we like. We have to be able to divide in powers of 2. So by doing this, so by turning these zeros into ones, we're creating 64 smaller networks that can accommodate 2 usable IP addresses, 1 network and 1 broadcast. And this way, when you configure your computers and you give them an IP address of, let's say, 148.197.30.55, and you're using a subnet mask of 255.255.255.252, because that's what these ones add up to, yeah, then your computer immediately will know that this is a network with a network address of 54 and a broadcast address of 57, because you've given it a subnet mask, so you've given it the network limits, so it knows what it's like. Okay, so the whole idea behind this is that we've created little networks for our little network neighborhoods. So essentially, if we go back onto the lab sheet, we have 2 usable IP addresses per little subnet that we have. So our subnet 30 will have those 2 IP addresses that are allocated to a specific computer. In exactly the same way, we give the IP addresses for subnets 31, again, 2 IP addresses on 31. So when you're reading this file, it can be the same for 30, 31, and 32, which is that third little branch here. So that's how we configure those IP addresses. So VMnet 0 and VMnet 1 will get the first usable IP addresses according to this. And then once you go inside, let's say VP0 on this network card, you will give it the second usable IP address according to the computer that you're sitting on. Now, once you have all of the networking information that you need, you just need to start up all of your virtual machines, go to the network card settings, and configure the IP addresses, default gateways, and everything else in them. Once you do that, you will have reached the end of the lab sheet, which is essentially your testing. So for you to be able to say that you've successfully completed this lab sheet, you need to be able to ping your neighbors. So you need to be able to ping from 0 to the host, so from 0 to the host, from the host to 1, and from 1 to 2, and vice versa. You will not be able to ping from any of your virtual machines to the outside world. You will not have internet access on them and everything, because the network is not yet complete, because they are on different subnets. And who can tell me what we might need in order to give internet access to them in the end?
Gateway?
We have a gateway. We have gateways on all of them. Yes?
Bridging?
Yes. Okay. So we will need to have routing, which is the next lab set after this. So we need to figure out a way to tell this guy down here, VP2, that look, if you want to go outside to the rest of the world, everything is out through your gateway and through this computer's network. And then this computer's routing table will tell us, oh yes, if you want to go to that way, you need to get information through this way. So everything to the outside world has a specific pathway, a specific route that you need to follow in order to go out. So we'll set up some software on Prometheus and on vPrometheus 1. That will be a routing agent, it's called FRR. And we will use that in order to build the routing tables in all our virtual machines so we can have internet access on all of them. Okay, so I will quickly recap this. It is a lot of information. Before you go to the lab to do this, please go on to this website and have a look at this. Okay, if you read through all of it, it will give you a better understanding of how CIDR works, and you will understand more about it. Yes?
Is that linked on Moodle?
It's on Moodle, yes. It's on Moodle. So, for this lab sheet, we need to build 3 virtual machines and we need to connect them together. In order to do this, we install VMware Player inside Prometheus. We fetch the ISO image for Rocky Linux from the host. We build 1 virtual machine. We clone it 2 times. We customize our network settings on the virtual machines by running the VM subnet script and the fixed VMnet dev script. We decide which IP addresses we need to use for each of them by consulting the a2.net subnets file. And then we go to the settings of all of the network cards in all of our network, give the IP addresses, subnet mask, default gateways, and everything else, and we try to ping our neighbors to make sure that the thing actually works. Okay, so this is essentially the recap of it. Any questions about this? Yes?
When would the lab for this be?
So the lab starts on the 4th of November. So this lab session would happen on the 11th of November. Okay, so plenty of time to have a look at the theory about it before that. Any other question? Okay, thank you very much.